Hi, so this is my flip video on the second technique of integration that we are going to learn, which is the substitution rule. The first technique, of course, is the only one that we knew so far was to use the power rule and the sum or the difference rule. The power rule and the sum rule are very useful, and you can do a number of problems with them. But if you take a look at a problem like what's here, then you will see that where we need to integrate x plus 1 to the power 7. Now, if we are going to use the power rule and the sum rule to integrate this indefinite integral, then we have a problem. And what's that? Because we have a seventh power here. So we need to really distribute this to 7 powers. So that's going to be a very difficult and long process. So what do we do then? Well, then in a situation like that, when we can't use the power rule and the sum rule directly, when you have higher powers, right, and things you can simplify to get the power rule and the sum rule, that's the time that we use this new technique. So the general way to use the substitution rule is this. You look at the most complicated part of the integral, right? There's no real way, but so here, the complication is rises because of the x plus 1 term, right? I mean, because if you had just x to the 7, we would have been okay. It was because we have x plus 1 to the 7, right? Then that's where the problem comes. So what we do is, if you can replace x to the 1 by some variable, say u, then you have u to the 7, correct? But u to the 7 is easy to integrate. U to the 7 is what? U to the 8 over 8. So it makes sense to, if I want to use the power rule, then to replace this x plus 1 quantity by a single quantity u. So that u is called a substitution. It's called a u substitution. So let u is equal to x plus 1. So now, one thing that we do is that we want to check whether our substitution is correct. So let me give you a kind of a rule of the thumb, and you will see later why this will work. Okay, the moment you decide u, differentiate it, du over dx, right? And then the rule of the thumb is whatever that you get when you differentiate the u, right, should be equal in style to the leftover part that you get in the integral when you plug in u. What do you mean by that? So you get du over dx is equal to 1. Now if you plug in u into the integral here, right, you get u plus 1 to the power 7th, right? And is there a leftover part? No, there is no leftover part. So you can kind of think as a leftover part as a number, or 1 really. So because you got 1 here, that means the derivative of the u substitution is equal to the leftover part. Now suppose you got 5 here, still it's okay because 5 is a constant, right? Okay, but if you get the leftover, the derivative to be x, for example, then we have a problem because the leftover part here is 1, but we have an x here. But we can go on to that a little later, but just make the mental check. The moment you put u, you differentiate the u and see whether that is equal to the leftover part in style. Alright, now let's get back to our problem. Okay, so now we have u is equal to x plus 1, so we go up here and we plug in for u. When we plug in for u, what do we get? This is u, this becomes u, so you get u to the 7, u to the 7, but we also have a dx, right? But what is dx? So how do we get dx? So remember, we got du over dx is equal to 1. We can solve this for dx. So when you solve that for dx, we get what? We cross multiply. So dx goes up here, the 1 goes down here, so dx is equal to du over 1. So we go up here now. So this is u to the 7. For dx, we replace the dx by whatever that we find here. So dx it becomes what? Du over 1. So finally we get I is equal to integral u, this is u to the 7 and du over 1, u to the 7 du over 1. Well, dividing by 1 won't make any difference, so this is the same as u to the 7 du. Now, integrating u to the 7 du is not hard at all, because now you can use the power rule, because your variable is now u and the integrand is just u to the 7. So you need to integrate u to the 7 with respect to u, and the answer will be what? You increase the exponent, you use the power rule, and the 7 becomes what? 7 becomes 8. So you can 8 to the u to the 8 and you divide by 8. But u is equal to what? Now this is the answer. We actually done the integration. So the answer is u to the 8 over 8. But this is not very how shall we say, conventionally good, because we can't leave the answer in terms of u, because we started the problem with x. We got to leave the answer in terms of x. So what we do is we replace the u by x, and then we get x plus 1 to the power 8 over 8 plus c. So the answer is x to the 1 plus the power 8 over 8 plus c. So once again what we did was we replaced the complicated part by a u, differentiated that, and we made a kind of a mental check to see whether the derivative is equal to the leftover part, and it is. And now we solve for dx. Dx is equal to du over 1, and then we take it and plug it up here, so this becomes u, so you get u to the 7, and the dx becomes what? Du over 1. So u to the 7 du, and that's, so you integrate u to the 7, you get u to the 8 over 8. And then the final touch is you just replace the u by x plus 1, and then your original substitutions, you get x plus 1 to the power 8 over 8 plus c. Let's take another example. Let's take this one. So we have to integrate x times x squared plus 5 plus x to the 5 dx. So once again we have a fifth quantity raised to the fifth power, which will be very difficult for us to expand. So in a situation like that, it makes sense to replace it by a substitution, because this is the troublesome part. We call that u. So u is equal to what? X squared plus 1. Now the moment you write that, make sure that you do the mental check. So what is the mental check? You immediately differentiate the u, and now you get what? The derivative of x squared plus 1 is 2x. Now check out here and see now whether that 2x is equal to the leftover part. Now what do you mean by the leftover part? See, if you take the u is this. If you take the u and plug it up here, you get u to the 5. So this piece is all u's, okay? U to the 5. What's the leftover part? The leftover part is x. But is that equal to the derivative? Well, it is, right? In the same style, because 2 is a constant. We don't care about the constants. But there is an x here, and there is an x in the leftover part, so which makes it a good substitution. The next step is to solve for dx. So dx is equal to what? To cross multiply, dx is equal to du over 2x. Now we are ready to plug back things. So what we do is we take this dx and we plug it up here. So when we plug it up here, okay, what do we get? We get integral I is equal to integral, okay. So how do you plug in back? Now this thing is u, right? So that's easy. So we call it u, and u to the 5, u to the 5. That's here. What about this x? Well, remember that was the leftover part. The leftover part should cancel off. So leave it as x. Don't touch it, right? So you have x times, I leave the x here. Replace the x squared plus 1 by u. So I get u to the 5 dx du. And then replace the dx. Remember, replace the dx. What is dx? Dx is equal to du over 2x. And now you will see that something nice happens as we expected, because the derivative had that x part, which is the leftover part also. Can you see that the x and the x cancels off? That is why actually we did the mental check here. That is why we checked whether the derivative equals the leftover part, because later on we would expect this to cancel. Now the x's cancel off. And why is it important for the x's to cancel off? Because we are trying to now integrate with respect to u. If you are trying to integrate with respect to u's, everything should be in u. You cannot have x and u both. So what you do is the x's have to cancel off, otherwise we are in trouble. Alright, so fortunately for us, the x's cancel off, right? Okay. And now what do we have then? We have u to the 5 right? And there's a 2 here, which we don't care, right? U to the 5, and then of course this is du. This is du, right? Okay. And now we take the constant, 2 is the constant, we take it outside, so that becomes 1 half, right? Outside the integral sign. And we just have to integrate u to the 5. Integrating u to the 5 is a piece of cake because you can just use the power rule, right? So what's the integral of u to the 5? That is what? U to the 6 over 6. Now we are literally done except that we need to plug in back for u. So what is u? U is equal to x squared plus 1. So you plug that in up here, you get what? X squared plus 1 to the power 6. Okay, x squared plus 1 to the power 6, and then this 6 and this 2 will join and you get a 12. So 1/12 x squared plus 1 to the power 6 plus c. Now that's the answer. Okay, that's the answer. Okay, everything in x. Now let's do one more example, right? And now this time we have x cubed over there. Now what would be the substitution? Once again, it's kind of very messy, so you can't use the power rule. Now remember once again that integration does not have a quotient rule. Okay, so you got to use the substitution. That's the only way out, right? So okay, so can we use the, so what do we call u? U or this or this? Well, if you call the bottom x squared x to the 4 plus 1 as u, then you are in kind of luck. Why? Because if you differentiate x to the 4 plus 1, you get 4x cubed. Do the mental check now, right? Now, if you plug in u here, what's the leftover part? The leftover part is x cubed, which is exactly what you have here except for the 4. We don't care about the 4. So now, if you solve now for dx, you get what? Dx is equal to du over 4x cubed. So now I'm ready to go. So that means it's a good substitution because the derivative is the leftover part. Well, if we don't worry about the 4. So good substitution, you solve for dx. So dx goes up and du over 4x cubed goes down. Now we are ready. So once again, when you plug it back in, this is replaced by what? The bottom. The bottom is replaced by u. So you get what? U squared at the bottom. So there you go, u squared. Can you see that? Right. What about the x cube? The x cube we leave alone. Okay, so x cube is something that we leave alone. And then we have dx is equal to what? Dx is equal to what? Du over 4x cube. You just replace the dx by the du. So dx is equal to du of x cube. So once again we leave the x cube as it is because we expect that to be cancelled off. This is replaced by u. So you get u squared. And dx is equal to du over 4x cube. So the x cube and the x cube will cancel off, and then you get 1 over u squared, and then you have a 4, and then you have du, and the 1/4 is taken outside, and then the 1 over u squared is actually u to the minus 2. 1/4 u to the minus 1 divided by minus 1, right? And then 1/4 and minus 1 is actually negative 1/4. And u to the minus 1 is actually 1 over u. So now it's the time for us to replace the u by x to the 4 plus 1. So it's negative 1/4, 1 over x to the 4 plus 1, and then plus c. So negative 1/4, 1 over u is what? 1 over x to the 4 plus 1 plus c. Alright, so you find, so the moment, okay, so once again, let me come back here. So the 1/4 goes out, you have 1 over u squared. Now if you want to use the power rule to 1 over u squared, then the u squared becomes u to the minus 2. So when you integrate u to the minus 2, the minus 2 becomes minus 1. Minus 2 plus 1 is minus 1. You divide by minus 1. So, and then if you collect the negatives, you get negative 1/4. U to the minus 1 is 1 over u. And then the final touch is you are negative 1/4, 1 over u is what? Once again, x to the 4 plus 1 plus c. Alright, that's it for this video. So we will talk to you in class. Okay.